In this video, we will learn on how to perform vector product. There are three main learning outcomes, which are find the vector product, use the properties of vector product, and find the area of parallelogram and triangle. So this is the situation whenever we perform vector product, or also known as cross product. So if we perform, let's say, vector A cross vector B, we will get a normal vector. What does it mean by normal vector? Our normal vector must be 90-degree or perpendicular to both vector A and vector B. So if let's say we have A cross B, our normal vector going upwards. If we perform it the other way around, vector B cross vector A, our normal vector will go downwards. How do we determine this direction? You can use right hand rule. So if we have vector A cross B, just moving using your right hand, so our thumbs will go upwards. So if it's the other way around, vector B cross with vector A, our thumb will be point downwards. That's how you determine the direction. These are the properties for vector product. Altogether, we would have 7 properties. So let's go through it one by one. For the first one, vector A cross vector B would be negative of B cross A. Why is this so? As I explained with just now, you just check it with your right hand rule. Next one, for the second properties, if we have A cross B plus C, it's basically the same as A cross B plus A cross C. You just have to expand the bracket, but then don't leave out our cross sign. If we have a constant M, so M times A cross B is basically the same as M cross M times with A cross B, and then basically the same as A cross with M times B. Remember, M in this case is a constant. Okay, number 4 basically follow the same properties as number 2. Next one, number 5. Whenever we perform cross product with the same vector, our answer must be 0 vector. 0 vector here, not a scalar 0, but then 0 vector. It is 0i plus 0j plus 0k. And then next one, if we have A dot with B cross C, that is basically the same as A cross B dot C. We can change the place for dot and cross sign. And last one, if we have A cross B cross C, it is the same as A dot B times, A dot C times B minus A dot B times C. For the application for vector product, we will learn on how to find 2 different types of area. First one will be area of parallelogram. Our formula for this one would be magnitude of A cross B, provided that our vector A and vector B are the sides of our parallelogram. Second one, we will learn on how to find the area of a triangle. So our formula is half of A cross B. Same as before, A and B are basically the vector for our sides. So now let's go through some examples. First one, if we have vector A and B, show that A cross B equal to negative B cross A. So this is the statement from our properties just now. So we will learn now how to find a vector product or cross product. So it is a bit complicated compared with dot product, but then not to worry. If you practice and do lots of exercises, this won't be a problem. So first one, if we want to perform the cross product, open up a big modulus. For the first row, it fixed I, J, and K. That is the notation for our vector I, J, and K. And then second row would be vector A itself. But then for this part, just take our coefficient. So now we will have 2, -1, and -1. That's come from vector A. That's going to be for the second row. And for the third row, vector B, just take all the coefficient from vector B. So we would have 1, 1, and -1. Okay, now we may start perform our cross product. So it is basically a bit following the step of on how to find a determinant. Kita akan tutup row dengan column tu. So our template would be fixed. Start with plus, open up one modulus, that's for vector I. Minus with, open up another modulus, that's for vector j. Plus with, open up another modulus, that's for vector k. So how do we find each number for each element? For vector I, just delete a row and column that cross with I. So what I meant here is I delete the first row and first column. So our number now would be -1, -1, 1 and -1. Okay, that's for I. Now, for element J, just delete a row and column that cross with J. So I delete first row, second column. Here our number would be 2, -1, 1, -1. And then last one, for element K, delete first row and then third column. So our number would be 2, -1, 1, 1. Alright, that's how we find each element. So next, we have to calculate this. Remember our formula. If we have A, B, C, and D, it is basically AD minus BC. So for the first one, we will get 1 minus with -1. So we get 1 plus 1. That's for I. Minus with, for the second one, we have -2 plus 1. That's for J. And then last one for K, we would have 2 plus 1. Simplify this out. Finally, our cross product would be 2I plus J plus 3K. Okay. So that's for the first statement, A cross B. Now let's check with our right side, -B cross A. Let's do another part for cross product. So for negative of B cross A, first step same as before, open up our big modulus with I, J, K on the first row. Second row would be negative of vector B. So here would be -1, -1, 1. And last row will be for vector A. So we have 2, -1, -1. Now, remember, start delete by row and column. So I just put a template first. So we have positive. And then vector I minus with vector J plus with vector K. So for vector I, remember, delete the first row and first column. So here we will get -1, 1, -1, -1. For element J, delete the first row and then the second column. So we would get -1, 1, 2, -1. Last one for element K, delete the first row and third column. We would get -1, -1, 2, -1. And last part, simplify this up. So for vector I, we will get 1 minus with 1 plus with 1. So here we will get 2I. And then next one, 1 minus with 2. And then we have negative outside. So plus with J. And then last one, 1 plus 2. So we get plus 3K. If we check, our answer here are the same. So we can conclude that basically A cross B are the same as -B cross A. Alright, now let's do another example about cross product. So we have to show that 3A cross 2B is 6 times with A cross B. Okay, so let's do one by one. 3A cross 2B. Remember, when it comes to vector product or cross product, first row will be IJK. Next one, for the second row, 3 times with vector A. So we will get 6, -3, -3. And then for 2 times B, we will get 2, 2, -2. Now, we may start delete row by and column. So for element I, we have negative 3, negative 3 to negative 2, I. Minus with, for element J, we would get 6, negative 3 to negative 2. That's for J. Plus with, for K, we would get 6, negative 3, 2, and 2. After that, just simplify this up. Our answer would be 12I plus 6J plus 18K. Alright, settle with the first one. Next one, we have to find 6 times with vector A cross B. As we already find vector A cross B from the previous part, so we just substitute this up. Vector A cross B is basically 2I plus J plus 3K. Simplify this up, we will get 12I plus 6J plus 18K. And let's check it out. Yes, our answer in this part are also the same. So we can conclude now that's basically 3A cross 2B is the same as 6 times with A cross B. And that's how you find a vector product or cross product between two vectors. Alright, next one. Example 15. So given that vector A and B, so find A cross B. So for this part, I just go through quickly. So we have I, J, K. For vector A, it's 1, 2, 3. And vector B is negative 1, 3, and negative 1. And then delete following our rule just now for I, J, and K. I skip that part. In this case, now our answer for A cross B would be negative 11I minus 2J plus 5K. Settle with that part. Next one. So we have to prove that A cross B is a vector which is perpendicular to vector A. So now we have two different vector. First one would be A cross B. I just try to sketch it here. We have vector A cross B. We have to prove that this is basically 90-degree with vector A. So you already learned this in the previous subtopic. Whenever we want to prove a perpendicular vector, just straight away use dot product. So now we perform vector A cross B dot with vector A. If our answer would be 0, then it is perpendicular to each other. So our A cross B from previous part, we already get negative 11, negative 2, and 5. Dot with our vector. Vector A is 1, 2, 3. Now our answer would be negative 11 minus 4 plus 15. Simplify this up, it is 0. So we can conclude that A cross B is basically perpendicular to vector A. Okay, next question. So we have to find a vector that length set 11 which are perpendicular to both vector A and B. So they didn't say that between A and B are perpendicular to each other. So I just assume they are not perpendicular to each other. Let's say we have vector A and vector B. So we now have to find a vector that perpendicular to both A and B. In this case, we call it as a normal vector because normal vector will be perpendicular to both. So how do we find normal vector? It's basically cross product between those two. So in order to find normal vector, we must find A cross B first. So A cross B in this case, same as before. Remember our step, we would have I, J, K. And then 1, 2, negative 1. After that, for B would be 1, 0, and negative 3. Straight away perform a vector product. We would get negative 6I plus 2J minus 2K. So that is the vector that the question asked for. But now, the question also asks to find a vector that is length of set 11. That is basically the magnitude. So now let's check our magnitude. I name it just now as vector n. So Now let's check our magnitude for vector n. This is 36 plus 4 plus 4. So this is set of 44. So we have a problem here because we want to find a vector with the length of set 11, but now our vector is set 44. So our next step, in order to adjust this, we have to find a unit vector. Why we do this? Because unit vector, magnitude of it would be 1. So if we want to find another vector with a specific length, just find a unit vector first. So remember, for unit vector, I use a notation of cap here. Our formula is fixed. The vector divided by its magnitude. So in this case, our magnitude is set 44 times with our vector. So negative 6i plus 2j minus 2k. And to double check, just make sure you calculate the magnitude for this one. For sure, it will be 1. Since the question asks to find a vector with the length of set 11, and now we have a vector with the length of 1, so just times this by set 11. So set 11 times with our unit vector, we will get now set 11 over set 44 times with our unit vector just now. Simplify this up, we will get negative 3i plus j minus k. And since we don't know the direction of our vector, what the question asks for, I just put plus minus at the front because if I refer back to the question, we have to find all vectors. Our answer are more than 1. So means that our vector, our normal that I sketch it, may be going upwards or it may be going the other way around for vector B cross A. So since I decide to find A cross B, I have to consider another vector that go the other side, that go the opposite direction. That's why I have to put plus minus at the front. So okay, so let's summarize back our calculation. So what the question asks for is we have to find the vector that have a specific length of set 11. And our vector must be perpendicular to both A and B. So since it's perpendicular to both, that's why first I find the normal vector by using vector product, cross product. Okay, after that, I check our length or the magnitude. We have a problem because our length now will be set 44. The question asks for set 11. So to adjust this, we have to find a unit vector first. That would be our next step. I find the unit vector. Why we do this? Because magnitude for unit vector is 1. So after we get a magnitude 1, it is easy for us to adjust our length. Since the question asks for set 11, I just straight away times our unit vector with set 11 to get a specific length of what the question asks for. So just times it by set 11 and simplify it up. But then consider both direction of our normal vector. We have to put plus minus at the front of our answer. Alright, so this is for example 16. Moving on, let's proceed with the application for vector product. We have to find the area of parallelogram. So let's just try to illustrate this situation. We have a parallelogram. What does it mean by parallelogram? Our side have the same direction. So let's just label it randomly. Now we have vector U and vector W with the opposite direction. To find the area, we must find the vector product between these two first. So we have vector U cross with vector W. Remember our step. I, J, K. And then we would have 3, 1, 2, 1, negative 2, negative 2. Next, you just find the cross product between these two. Your answer should be 2I plus 8J minus 7K. And then next part, to find the area, it is basically magnitude of U cross W. So now we would have set of 4 plus 64 plus 49. Simplify this out, we would get 3 third 13 unit squared as our area. And then last question, example 19. So we have a triangle with three different points, point A, B, and C. Okay, so we have A, B, and C. For the first part, find vector AB and AC. So this is basically direction vector. You already learned on how to find this in 5.1. So for vector AB, remember, it is not A plus B and not A times B. It is OB minus OA. So find vector B, OB, negative 1, 2, 0, minus with vector OA, so 2, 0, 3. In this case, our answer would be negative 3 to negative 3. Next, find direction vector AC. So it would be OC minus OA. So we would have a vector 2, 1, negative 3 minus with 2, 0, 3. And in this case, our answer would be 0, 1, negative 6. Settle with part A. Now, part B. Find the area of our triangle. So, in order to find the area, first also perform the cross product between two sides. So, in this case, if we have a triangle with 3 points, you have 3 options. So, either you cross AB cross AC, or BA cross BC, or CA cross with CB. I just write it here. To find the area, we have 3 options. AB cross AC, or BA cross BC, or CA cross with CB. But then since from part A, we already find AB and AC, just use that for our next part. Okay, so AB cross with AC. When it comes to cross product, remember we must use a modulus IJK of negative 3 to negative 3 cross with 0, 1, negative 6. Simplify this up carefully. Delete row and column for each element. You will get negative 9i minus 18j minus 3k. And then last part, to find the area, it's basically half of its magnitude. So it's half of magnitude of AB cross AC. So half times with third of 81 plus with 324 plus with 9. So our final answer for this part would be 3 third of 46 over 2 unit squared. And that is basically how you find area of a triangle by using vector product.